Let's continue problem 1. After we calculate, draw the diagram, apply the CPM algorithm, and review the probability, now we can be able to answer for each of the question here. First, what is the expected completion time of this project? What is the expected completion time? Then with that, basically the critical path. From our calculations, we have two paths. The first path is ABCE, 107 days, and the path ADE, 72 days. So the expected will be the longest path. So the expected completion time should be 107 days. Okay, so that is the first A. We can write down expected completion time of this project equal to the critical path, and that is equal to 107 days, the longest path and here, and that equal to basically the t along the path, and let me call that T capital just for a path A, B, C, E. And you have that path there, 107 days. Now a bit more challenge from now B. The question is, what is the probability of the house within 107 days, the completing the house within 107 days? So what is the probability of completing the house within 107 days? So that basically the question become, if we model with the math, so that the probability of the project finish within 107 days, it means that finish at 107 days or earlier. So it means that X have to be less than or equal to 107 days. That is the question asked. And as you can see, yes, project, let me draw the distribution of this project. Schedule. Here, so we have a probability and we have these days for the horizontal, and as you can see the expected completion time, so in that the intersection here basically is 107, and standard deviation for that path A, B, C, E equal to 896 days. So you can draw the distribution is something like here, normal distribution along the path. Let me draw a little bit. So a bell shape, and it's symmetric. You see that there. So the probability of finish 107 days or earlier, basically 107 days or earlier. So it measure by these areas, and as you can see, it's symmetrical, so that the whole area under the curve is equal to 100%. So this one, half of that symmetrical. So without any calculation, you can be able to find out that is 50%. Make sense? And then now we go to the next B. Net B's. If you want to continue to find out why 50%, you are not sure, then you can use the table as well. So let me go to here to find out why 50%. You can find out G score equal to X minus X bar over sigma So we have 107 minus 107. X bar in this case expected divided by sigma is 8.96 days. So 8.96. So equal to 0. So when z equals 0, we can go to the reference with the 0. So you can get that is 50%. Z equal to 0. That column, you can get that 50%. So as you can see, go back here, you can use table. We can get probability of x over 7 days, 50%. So you can use intuition, or you can use the equation. Now move to C. C is what is the probability of completing the house within 120 days. So 120 days in this, so it's something like here. Let me draw that something like here. 120 days. 120. Then within, so we have the what is the probability of the project finish within 120 days. This is the question asked. Then with that we can use the same. We find out G score for 120 days, so it equal to 120 minus x bar, that is the expected duration, 107, divided by the standard deviations, 8.96, and that one equal to 1.45. And then we use table again. Use table. From this I can use table to find out p values. P values. P. Use table. And again, z is 1.7 1.47. So how can I find out? So you go to the first column, find out 1.4. We have 1.47. So in the first row, we look for the second digits after the decimal, because 1.47. So that is 0.005. And intersect of those two, we can be able to find out the probability. So 1.7, the p in this case equal to 0.9665. So from that we can have that p equal to 0.9265 from the table, and how to read that here. And with that, as you can see, I just make a note here. If p x less than x, probability of x less than x, then use G-score table and we can read directly from that. So here the probability of the project finish within 120 days is equal to 92.65%. So that is the answer. And of course, you see the answer too. So why 90 is more than 50%? And you can see the area on the left of the 122. So we can add another areas, another red, another, let's see, that here, blue area that you have here, plus the 50%, then you get the total areas, and it's greater than, much greater than 50%. And go to D. What is the probability of completing the house between 100 days and 120 days? So what is the probability of finish that in there? So let me erase is 100 days, 107, 120. So 100 days. So it will be somewhere here. 100 days. And we need to find out that areas and these areas, the area between the black areas and then the blue areas, as you can see there. So the probability of the project finish between 100 days and 120 days. So we have that is greater than x and less than that one. And with this, we can apply the equation here. Probability. So x between x1 and x2 equal to p x less than x2 minus p x less than x1. So with that one, what is that? Then we can find out the p 100 x 20 is equal to p of x finished within 120 days minus the probability of project finish within 100 days. In other words, it equal to the whole thing from the left of 120 and then minus the left of 100 in this diagram, as you can see. Then we already know at C the probability of x less than 120 days. We already know that in 92.6%. So this one we already find out in B, which in C that in 92.65%. We only need to find out what is the probability of project finish within 100 days. And at your expectation, it should be less than 50%, right? Because on the left of 107 days. So let's find that out. So we only need to find out the probability of finish less than 100 days. So that I can find out the Z for 100 days is equal to 100 minus 107, the x bar divided by the standard deviation, that is 8.96, and that I get negative 0.78, and it's less than 0 negative. So if you go to here, our Z is all positive, all positive. So how can we do that with our table? How can we do that with our table? If it's positive and you find out it's negative, then you just with the Z flip for positive. So you have with Z here positive 0.78, a positive number, whatever you find out, but forget the negative for now. Then you use the table, and to find out P, of the positive number. So 0.78, let's go to table. So let's go to 0.7, the second digit that here. So the intersect of that is the 0.7822. So we have that one here, 0.7823. Is that right? Go back. Yes, 2823. Then from that one, and actually that is the probability of project probability of the projects greater than 108 days. 108 days, because that is we flip the positive. So with that one here, we can be able to determine what we're looking for is less than 110 days or 100 days. So we have P of x less than 110, you just flip it equal to 1 minus p of x 100 days greater than, so that let's write down here the p of x greater than 100 days. If you flip the side of your g's and determine from that. So with that one here, we can have 1 minus 0.7823, and that equal to 0.2177, and that based on our projection, it have to be less than 50%, which it makes sense in here. So from that, we can have the probability of x greater than 100 and less than 120 days. It equal to the equation 92.65% for probability of less than 120 minus 21.77%. So you get is 70.88%. So that is the probability of the project completing between 100 days and 120 days. Let's move to the last equation, the last question. What is the probability with a probability of 80% when the house is completed? So now they ask time, give you probability. Then what we do? Basically, the question asks like this. What is x? So that the probability of within that x equal to 80%. And 80% is equal to 0.8. So we can use the table. So let's go to the table, and now it's opposite. Let's erase the previous problem. Find out where is the probability of 80%. So let's find out in here. So you see that the two number here either between, we don't have 0.8 exactly, but we have that somewhere between those two numbers. And as you can see, with the approximate, the closest is 0.7995. It's almost 80%. Almost 80%. Then we just make our life easy. We can get that equal to 0.84. So from that number, we can be able to find out 0.84. The closest numbers is here. Or you can interpolate. You interpolate between 0.7995 or 0.8023. Just make our life easy. Just assume that it's very close. 0.7995. So as you can see from the table, we can have P from table. With P equal to 0.7995, we have Z equal 0.84, and we have P equal to 0.8023. We have Z equal to 0.85. So it's very close to, so you can say interpolation, or you can pick 0.7995. So but I just use that for remind here by interpolation, and you know how to interpolate that by now. We have Z equal to 0.84, point something, but get that for P equal to 0.8. Then now we can be able to find out x from that P, from that Z. So how? Now then we plug in, we have Z equal to x minus x bar, so 107 divided by standard deviation 96, and that equal to 0.84. Then we have x, that is the question asked, equal to 0.84 times 9.9896 plus 107, and we have x equal to 115 days. What does that mean? The project finish if the within project finish within 111 day 15 days, then the probability to complete is 80%, which makes sense. 120 we have probability 92, 107 50%, so the 80% is somewhere between that, so you can see that is C is somewhere in here, 115%. That is 115 days, and that probability 80%. So that we done for problem 1.